Hey, what's up guys? So in this video we will learn about fluorine. Fluorine is a chemical element with the symbol F and their atomic number is 9. It is the lightest halogen and exists at the standard condition with the highly toxic pale yellow diatomic gas. So, as the most electronegative reactive element, fluorine is extremely reactive as it reacts with all other elements except for the light inert gas, that is group 18. Okay, as you can see here, the symbol of fluorine is F, while the atomic number of fluorine is 9, and the electron configuration of fluorine is He, 2s2 and 2p5. Another electron configuration of fluorine is 1s2, 2s2 and 2p5.
Next, discovery of fluorine. Fluorine, it was first described in 1529 by Gregorius Agricola for its use as a flux. In 1813, Sir Humphrey Davy experimented with fluorspar and attempted the extractions of fluorine but failed. Churchill was able to produce a small amount of fluorine through electrolytic process in 1869. It was successfully isolated by Henry Moissan, a French chemist, in 1886. He achieved this through the electrolysis of potassium fluoride and hydrofluoric acid in 1906. Henry Moissan won the Nobel Prize in Chemistry for his work in isolating fluorine from its compound.
So next I'll be discussing about the physical properties of fluorine. So next I'll be discussing about the physical properties of fluorine. These are the four main physical properties of fluorine. The first one is the color. Fluorine is a faintly yellow gas with an irritating smell at room temperature. When cool, the gas will change to yellow liquid. The second one is melting point. Fluorine will change from solid to liquid state at 219.62 degrees Celsius, which means that is the fluorine's melting point. And the third one is the boiling point. Fluorine change from liquid to gas state at negative 188.14 degrees Celsius, which states the boiling point of the fluorine. And the fourth physical properties of fluorine is its density. Fluorine have a density of 1.696 gram per liter. Next, we'll be discussing, next is the fluorine color in room temperature. This is the fluorine color in room temperature. It is a slightly yellow. And this is the fluorine color when cool, which means just now is the fluorine color, the gas fluorine color, but now it is the liquid fluorine color. Next, we'll be discussing about the chemical properties of fluorine. There are four chemical properties that we'll be discussing about today, and the first one is the electronegativity of the fluorine. Fluorine is the most electronegative element in the periodic table of element. This means that fluorine attracts electrons more powerful than any other element can. The second one is their reactivity. Fluorine is the most chemically reactive element. It reacts often very vigorously with all of the other elements except oxygen, helium, neon, and krypton. The third chemical properties of fluorine is their ionization energy. Fluorine has the highest ionization energy. This is because it has the tendency to gain an electron rather than losing an electron, since it has 7 electrons in the outermost shell. And the fourth chemical properties of fluorine is their isotopes. And fluorine has only one stable isotope, and that is the fluorine-19.
Now, let us learn more about halogen group element fluorine by looking at applications and disadvantages in real life. Many of the applications of fluorines include refrigerant, polymers, dental care, PET scanning, fluorescence, cryolite, medspar, and pharmaceuticals. Now let us go through one by one. First is refrigerant. It is widely known halogenated refrigerants, Freon. One of the examples of Freon is CFC, which is used widely in 1980s, where they are used in air conditioning systems, propellants, and solvents. Due to harmful effects, they are replaced with hydrofluorocarbons, known as HCFC, and hydrofluorocarbons, HFC, which their synthesis consumes more than 90% of fluorine in the organic industry. As of late, nowadays, hydrofluoroolefin HFO come into prominence due to its global warming potential of less than 1% that of HFC 1348. Another application of fluorine is polymers. Polymers of fluorine, for example, is polytetrafluoroethylene, PTFE, or known as Teflon. Teflon is used to make electrical insulation due to its properties of excellent dielectric. Another usage of Teflon is coatings in pipes, tubing, and gaskets due to its properties of corrosion resistance. Teflon also used in fiberglass cloth, good for stadium roofs or non-stick cookware and protective apparel. Another polymer of fluorine is naphthalene. Naphthalene is more like Teflon but more moldable. It is used to make electrochemical cell membranes due to its chemical resistance. And another polymer of fluorine is a biton, which is fluoroelastomer. It is used to make O-rings, which is a mechanical gasket. Another example of polymer of fluorine is perfluorobutane, which is used in fire extinguishing agent. Next, dental care. It is widely used in mid-20th century, where many research shows that fluoride can reduce dental caries. So, water fluoridation shows significant reduction in tooth decay. PET scanning. Isotope of fluorine, which is fluorine-18, is commonly used for radioactive traces for positron emission tomography due to its half-life of almost 2 hours, long enough for its transport to imaging centers. For example, fluorodeoxyglucose. After it is injected through intravenous injection, it is taken up by glucose requiring tissues such as brain and lung tumors, which shows the tracing property. Next, fluorescent. Fluoropatite shows fluorescence properties, and it is used to make fluorescent to cryolite. Sodium fluoroaluminate, or known as cryolite, is used to reduce aluminum oxide to aluminium metal by electrolysis. Next part. Calcium fluoride is used for iron and steel casting and making by lowering the melting point and increase the fluidity of the slag. Last but not least, application of fluorine in pharmaceutical. A fluorine atom in a bioactive material can simulate a hydrogen atom. Some organofluorides are highly lipophilic, which they increase the lipid solubility and thus accelerates the absorption and transport in a living organism. Next, disadvantages of fluorine can be described in toxicity, hydrofluoric acid, atmosphere, and bioresistance. First, toxicity. Fluorine is highly toxic to living organisms. In humans, significant irritation of eyes and respiratory system, liver and kidney damage can occur when fluorine above 25 ppm. Eyes and nose seriously damaged at 100 ppm of fluorine. An inhalation of 1000 ppm of fluorine will cause death in minutes. Second, hydrofluoric acid. Even though hydrofluoric acid is the weakest among hydrohalic acid, it is able to attack glass, concrete, metals, and organic matter. Hydrofluoric acid also is a contact poison with greater hazards than many strong acids like sulfuric acid, even though it is weak, where its properties is that it will be neutral in aqueous solution and thus penetrate tissue faster, whether through inhalation, ingestion, or direct contact of the skin. Another disadvantages of fluorine is towards atmosphere. Fluorine has ozone damaging potential, where fluorocarbon gases are generally greenhouse gases with global warming potentials of about 100 to 10,000 times. Their high stability meant that they were not decomposing until they reached the higher altitudes where they attacked the ozone molecules. Last but not least is bioresistance. Organofluorines are considered bioresistant, which means they are known to reside in breast milk and blood of newborn babies. In body, organofluorines bind to proteins and tend to concentrate in liver and blood before excretion through kidney. High doses of organofluorines can cause cancer and death. For example of organofluorines are perfluoroalkyl acids, perfluorooctanosulfonic acid, and perfluorooctanoic acid.
Fluorine has many uses in our life. For example, it is found as fluoride in the toothpaste and drinking water, in Teflon, drugs including the chemotherapeutic 5-fluorouracil, and many others. Fluorine is also used in refrigerant such as chlorofluorocarbon or CFCs, in pollutants, and for enrichment of uranium by UFC gas. But fluorine is not an essential element for the human and animal nutrition in life.